So the twin paradox. If you have already watched a bunch of videos on YouTube about it and you still don't understand it, you're in the right place. Twin paradox has boggled my mind since I first heard about time dilation from my brother when I was like 11 years old. He explained to me the concept with the twin paradox. He explained to me time dilation with someone traveling from Earth to another star, then coming back, and he has aged less. So my immediate question then was, why is it him that is getting older? After all, you could also see that the Earth is moving away from me and then the Earth comes back. Yeah, he didn't really have an answer for me, at least not that I would have understood at the time. And that question really stuck with me for all my life now. I recently went into a frenzy watching videos about the special relativity and general relativity, and I finally got what was boggling my mind. But I still think that all the videos did not address that point. There are a lot of good videos that do the math well. Minute physics showed that when they move away from each other, they both perceive the other time going slower. But once the person that traveled away from Earth decelerates and comes back, he basically jumps over time. So that's a pretty good explanation, but it still doesn't address one point. So this all happens then within the acceleration, right? Well, it is not about the acceleration. The moving part is enough. You could have an experiment where one guy travels away from Earth, and instead of stopping, accelerating and coming back, another spaceship is coming by him, reading his clock and adding it to the time until he arrives back at Earth. So that all makes sense now. It's not about the acceleration, but this still is not addressing that was boggling my mind. I thought it would still be a symmetrical situation, because no matter what kind of mathematical transformations you do after he comes back and that math checks out, you could do the same mathematical equations if you look at it from I'm standing still, the Earth moves away from me, and then the Earth comes back to me. So I thought. Now the argument could be, no, I'm the one that is accelerating, right? But then we get told it's not about the acceleration. And if you want to do this without acceleration, you could do the same experiment with someone else reading Earth's clock. The Earth is the one that is accelerating. So the real question still is, who is the one that is accelerating? Because if you imagine a universe where it's just one guy on Earth and me, I could also be the one that stands still. The Earth moves away from me, and then the Earth would change its speed, move away from me slower. Earth changes its speed and comes back. So what is acceleration? Acceleration is just changing of speed, right? So you could also see the Earth moving away from me. I'm standing still. The Earth moves away from me. Then the Earth changes its speed, moves away from me slower, and then accelerates back to me. And that is the point. That is not the case. If you have a universe where you only have you two guys, then you couldn't tell who is accelerating and who is not. But if you have a third observer, someone that stands in the middle between the two of you or somewhere else, he can tell that only the spaceship is changing its speed. So we all have been indoctrinated, at least if you only learned about physics from YouTube videos, that all is relative. That is the way I thought. But there is no absolute speed, because that could also be seen in another life. But there is absolute acceleration. So in fact, you can actually tell that the spaceship traveling from Earth was the one that was accelerating. And therefore you could kind of also already tell that the spaceship is the one that is flying away from Earth while the Earth stands still. Still is a relative point. The Earth is still moving and so on. The speed is not what is absolute. The acceleration is. And that is the point. It's not a symmetrical situation. So what about the video where he was saying it's not about the acceleration though? Well, you could do the same thought experiment he did with the third guy coming across. You could also do that with the Earth. If I'm really standing still and the Earth moves away from me, same thought experiment with another guy flying to me and past the Earth and writing the clock of the Earth. So you could do the exact same thing if the guy that is flying away from Earth is not the one that is accelerating. And that is the point. Is this somehow groundbreaking or something? No, they all know it. This is just obvious to them. It was not obvious to me. And it is kind of crazy if you think about it. If there's absolute acceleration, there is kind of also absolute movement, because you can tell who's moving from whom. You could also argue that acceleration is a real thing because forces are applied. You could feel that he's the one that is accelerating while the Earth doesn't feel it's accelerating. But my argument to that was, what if there is a force that is accelerating everything in your body, including the senses that track the acceleration in the same way? Then you wouldn't feel it. A stone does not feel that it's accelerated. The other test is that the physics in the accelerated frame do not behave the same way as in the non-accelerated. If everything is moved by a uniform force, then physics would still move in the same way. If you want to see gravity as a force, that would be one of those forces. Now that brings some other problems with it. So I might do a video about general relativity as well and why things fall. But reality is there are only so many forces out there, and gravity is not really a force. So the other forces all have particles actually transferring those. So in our universe, at least the discovered forces, you can all track them. They are a real thing. So you can actually say that forces are applied to him and he is the one that is changing speed. There's one more thing that you gotta be a little bit careful about. So I said the third observer can see who is accelerating and who's not, right? Well, if you have a guy really on Earth and another guy falling towards Earth due to the gravity, outside observer far away from Earth would see the Earth standing still and the other guy changing his speed, accelerating towards Earth. So that's the guy that is accelerating, right? Well, wrong. Acceleration does not really mean change of speed, but taking a curved path through space-time. In case of gravity, this is like really mind-blowing again, but the guy on Earth would be the one that is accelerating in that case, and the guy falling to Earth would be not. So in the twin paradox, it's a little bit unfortunate that the guy that remains on Earth is also within a curved space-time or on Earth and gravity forces are on him. So an outside observer cannot really trust his eyes for who is accelerating to whom. But forces are real things, so someone is accelerating. If someone is accelerating, you could ultimately tell who's moving from whom. This doesn't contradict any of relativity though, it's just, it never was about the acceleration. I just didn't understand that. If you want to make physicists really mad, you can talk about the ether. So I'm not gonna do that. I'm just gonna read some sides to you. I'm gonna read a quote from Robert B. Laughlin, who is a physics Nobel laureate at Stanford. He wrote in 2005, "It is ironic that Einstein's most creative work, the general theory of relativity, should boil down conceptualizing space as a medium. And his original premise in special relativity was that no such medium exists." And A.P. French wrote in Special Relativity, "Note though that we are appealing to the relativity of acceleration and to the observability of inertial forces associated with it. Would such effects as the twin paradox exist, the framework of fixed stars and distant galaxies were not there?" Most physicists would say no. Our ultimate definition of an inertial frame may indeed be that it is a frame that is having a zero acceleration with respect to the matter of the universe at large. One note, I disagree though. There wouldn't be anything in the universe but those two guys. One would move away from the other and then would come back. Well, you couldn't tell who is moving from who, but if space is the same way as it was before, you could tell by seeing who aged more. Then you know who was the one that is accelerating. And it's still crazy and mind-blowing to think about that. It is the moment where the other guy comes back, where he jumps over time. The Earth, out of his perspective, the Earth so far has aged less. But once he did the acceleration back, and this could be happening within an hour or a minute, and within that hour, maybe he jumps over 500 years and the Earth all of a sudden aged 500 years in the hour that he accelerated. That is crazy to me. But it seems that is the way it is, and now you know that this is not a symmetrical situation and you know why. It took me almost 30 years to understand that. I might save you time.